All right. Theoretically, I'm about to stream myself checking the stats. I will trim this out of the recording for sure. Okay. So, this is Tdd 101 using JavaScript and Jest. And I'm creating this video to try to help people learn how to do test-driven development, people who are familiar with JavaScript. For this example, I'm using WebStorm, basic NPM, and Jest. I'm not doing anything special. The repository is on my GitHub account, which is github.com/rdomkaler. And basically what we're going to do is just implement FizzBuzz using Tdd, and we'll talk a little bit about how Tdd works, walk through some of the basics. This is really designed for, true beginners. The README file does contain explicit instructions and detailed instructions on how to download, install, setup, etc. All of the things, including setting up NPM. So let's just jump right into it, right? Let's talk about, well, what is TDD, right? So test-driven development. It's a simple process used to develop software. And we start with the Tdd Microcycle. So the Tdd Microcycle is very straightforward: red, green, and refactor. When we're red, that means that our code doesn't run or doesn't pass its tests. When we're green, it runs and it passes its tests. And refactor is the cleanup step that we do in between red and green. You only ever want to refactor when you're green, because it's hard to tell if you broke anything if the tests don't pass, right? So let's talk a little bit about FizzBuzz. FizzBuzz is a children's counting game for teaching division. Where the specification is right here on the screen. Write a program that prints the numbers from 1 to 100. For multiples of 3, print fizz instead of the number. For multiples of 5, print buzz instead of the number. And for multiples of both 3 and 5, print FizzBuzz. Pretty straightforward, simple thing. I picked this simple thing because we don't have to think very hard about the problem, and we can focus on learning TDD. So, first things first, we're going to need a test, right? Let's add a test file. Right click. I don't think you can see, maybe you can. Can you see the pop-up menus? Of course not. That would be too easy. So I'm going to add a new file. I'm going to name that file test/FizzBuzz test.js, and it's going to create that file for me. And then I'll add that to GitHub, or to Git right away. I'm not here to teach Git, but I recommend that you use some kind of source control like Git or whatever else you might choose to give you the opportunity to roll back easily and not lose your work. So FizzBuzz, let's focus on the first rule, right? First rule, given a number, return that number as a string. So it's implied, because we're going to return fizz or buzz in other cases, that the return type is probably string, since there's no numeric representation of fizz and buzz. So Jest is a pretty straightforward framework. We say we want to create a test by saying test. That's easy, right? We give that test a meaningful name. When I think about the meaningful names for tests, I think about I'm already in a file called FizzBuzz test. So I don't need to repeat myself and say FizzBuzz again here. I can simply say given 1, return 1, and I'm putting ticks around it to indicate that's a string. A lot of people ask, well, how do you know what's the first thing to test? And I rely on James Grenning's zombies concept of testing for 0 input, 1 input, many input, boundary conditions, interfaces, and exceptions, and then standard stuff, right? So what would be the first most obvious thing that I would do? Probably see what happens when I give it 1. Are there some exception cases outside of the boundaries of the question? Absolutely. Negative numbers, 0, floating point numbers, things like that. What should the system do? We're not going to worry too much about those exception cases. We're just going to try to get down the mechanics of TDD here. And so for a starting point, I'm picking the obvious thing. What's the first thing that would be returned? Would be, I would give it 1. It gives me back the string 1. So again, in Jest, I then just declare a function. And I say, okay, so what's my test? Well, I want to assert. So in Jest, if you can spell, you would type expect the result to be expected. That's straightforward enough, except, you know, result and expected aren't defined. So let's go define those. Let's say const result is equal to our FizzBuzz method given something. Const expected is 1. We said that up here, right? We expected to return 1. And we just declared another variable called given. So what is that? Const given 1. Little source code formatting action. So we have our first test, and that's the first thing we do. Now, we're going to try to run that test, and you can guess it's going to fail. We haven't defined FizzBuzz anywhere. And that's an important thing to keep in mind when you're test driving, is not compiling is considered the red state. So this is not, you know, refactor time or improve time or write another test time. This is figure out why it doesn't run and fix that. So we don't have a method named FizzBuzz anywhere. So let's go create that. Now there's two approaches here, or probably more than 2, but there's at least 2 approaches here. One is, let's go ahead and create FizzBuzz, the method, inside the test code so we don't have to mess with wiring this up to production code. The other one is, let's go put it where it would be in production so that we've wired up our test harness against that and we don't have to come back and do that work later. I prefer the latter. So I'm going to go ahead and I'm going to create a new file. And you, again, I'm sorry you can't see the pop-up, but I'm going to type in src/ index.js. And I'm going to add that code, that file to source control. So now I have this new file, and in here I'm going to define a function. Function FizzBuzz takes given, does nothing, and then I need to export that because that's how JavaScript works. So module exports equal FizzBuzz. It's the only thing I'm exporting. I don't need brackets or anything crazy. I've now exported that. I'm going to come back here, and I'm going to say const FizzBuzz is equal to require ... src index.js, and I'm going, or just index, and then I'm going to run, and this should work and give me an error. I didn't get what I expected. So yes, expected received to be expected, object equality, so expected a 1 as a string, and I received an undefined. And we know why, right? We know why because we didn't write any code to do anything. So let's go in here and write the simplest thing that could possibly work. So this is a key to TDD. Don't write a big statement, don't write a bunch of complicated code and try to figure out 14 things at once. Solve just for the test case, write the minimum amount of code for that test case. So in this case, we're going to return the string 1. And we're going to hit play, and it's going to run that test, and it should pass. And it does. Look, 1 test passed. Cool, we're on our way. So let's talk about the mechanics of TDD a little bit more, right? We've talked about red, green, recycle. What about the structure, and what about the way that I approached building this test? So structure first. This is setup, or arrange. We're saying, this is my given and this is my expectation. I'm arranging the test. There could be other steps here like instantiating objects or, setting passwords, doing other things, right? But for a simple thing like FizzBuzz, all we have to do is say, hey, I'm given 1, I expect 1 as a string. That's cool. The next structural thing, right, is to execute the code under test, or act, right? Setup, execute, I got a result. Now I want to test it. So here, assert, which is also assert, right? So setup, execute, assert, SEA, C, easier to remember, or AAA, arrange, act, assert. Either one of those will work for how do I remember what this is. And you might even hear other people say, given, when, and then. It's another way to remember what we're doing, right? So given some set of conditions, when some action occurs, some activity happens, then I expect something to be true. That's the structure of all tests. In other contexts, we might also have, some cleanup step or something if we've done an integrated test where maybe we wrote to a database or a file, but we're not going to worry about that. FizzBuzz doesn't need any of that stuff. We'll do it in another presentation. So we've got this structure, right? You noticed when I wrote the test, or maybe you didn't, that I started at the assertion. What am I trying to prove? That guides me to, well, in order to prove that I need to define some stuff. One of those things would be the execution. And the next thing would be, well, what do I need to do to set up that execution? So I start at the bottom and I work backwards from the expectation as I'm starting to understand. And this helps me define things in terms of the output and prevents me from accidentally influencing my implementation with, well, but I did all this stuff in setup. Let's borrow that variable or any of that stuff. Keeps things pretty clean, pretty straightforward, right? So again, we've taken like the babiest of baby steps, right? We've got this first test. We've said given 1, return 1. We run that. Look at us. We're going to pass. Those comments didn't impact anything. That's great. We like that. You should always be running your tests, right? You should run your tests as frequently as possible. Some frameworks provide auto runners that'll run your test continuously. Every time you hit save, it just runs the tests for you. I'm not doing that here because it makes the presentation difficult, but you may find running an auto tester to be super helpful. I'll try to remember to add to the README some notes about where to get an auto tester for the various frameworks. So anyway, let's go on to the next test. So we've got this implementation, right? All it does is return 1. Well, that's certainly not going to meet the expectations of the whole application. So what would be the next thing? What would make sense next? Probably something like 2, the next number, right? So test, given 2, return 2. Easy, right? Simple description. And we're going to say, in this case, const given 2, const expected equal 2. By the way, I use the word expected here because if you use expect, it gets confused with jest. So the grammar seems a little stilted, but I made that mistake while I was practicing, and I was like, why isn't this working? It's okay, it's just a mistake. So const result equal FizzBuzz given expect result to be expected. Cool? Very straightforward. It's basically the same exact test except with different input and output variables or inputs and expectations. And that's okay, right? So one of the things that we face now is, well, what do I think is going to happen when I run this test? What I think is going to happen is we're going to run this test and it's going to say, given 2, I received 1. That's pretty obvious, I think, to most of us. But if it's not obvious, think about, well, what implementation do I have? Always return 1. So it doesn't matter what my given is. So this test is exercising that edge of, well, what if it's a different input? This is important because when we're writing tests, when we're doing TDD, what we're thinking through is, well, what are all of these boundary conditions and edges and things inside the system that I need to exercise to make sure that I'm delivering the full solution? And this might lead to conversations with product owners or other developers or the QA people on your team for, well, what should I be testing? What other things could be true that I need to make sure I'm doing the right thing? Right? Again, this is a trivial case. We know what the next thing is. 2 should return 2. We have an expectation that when we run this, we're going to get a 1. And when we run it, if we don't get what we expected as a failure, we need to pause and say, well, why didn't I do that? Why didn't I get that expectation? So, as an example, yesterday while I was doing this in a practice session, I made a typo and I got an error saying that function isn't available. And I glossed right over it and kept on going like, oh, I'm really smart and I know what I'm doing and it'll be fine. And no, it wasn't fine, right? I had a typo. And so I kind of dorked around for 2 minutes trying to figure out what mistake I made. And I realized the mistake I'd made was a typo. Got my parentheses in the wrong spot. When I fixed that, everything went back to normal. So it's important to just, take a moment, take a beat, look at the error message, if there's an error message, and say, well, what happened there? So let's run this. And it says, 1 failed, 1 passed, 2 total, cool. Look at the failure. Given 2, returned 2, expected received to be expected. Expected was 2, I received 1. This is the error message I expected to see. Okay, cool. So at least I know that it failed the way I wanted it to fail. And I can say, all right, well, what do I need to do? What's the simplest thing I can possibly do to make this work for 2? Now, some people might even go so far as to put an if statement in here and say, given 1, return 1, given 2, return 2. I'm going to take a slightly larger step because JavaScript makes this easy for me. I'm just going to call toString on given. That's the simplest thing I can think of without just sort of taking it too far, right? And I'm going to hit run. Now, if this is going to work, I know it's going to work. But if this didn't work, I would say, well, maybe I took a step too far. And I could undo the change. And I could say, if given is equal to 1, return 1. If given is equal to 2, return 2. This should also pass. But now I'm going to have to repeatedly write this test over and over and over and over again for every possible number in our scope, which is 1 to 100. That seems tedious. So I'm looking at this and I'm saying, well, what's the pattern here? I'm just converting that thing into a string, right? So return given toString, and we're back to green. Awesome. So let's go commit that into source control. I will type the commands out instead of using my shortcuts. Git status says there are 2 files here. They've been modified. What do you want to do? I'm going to type git commit -a will commit all the things on the stack. -m will allow me to type in a message. And the message is first rule number toString. Git status. Everything's cool. I can run again just to make sure that I didn't do something crazy. I know I didn't do something crazy, but I can be very careful about it. Look, things are still passing. So let's go back to playing with these tests. Let's look at this. We're green, so we can do refactoring steps. I'm going to throw away these comments. Don't need them. They're just cluttering things up. I put them in there to illustrate. I've got these basic steps, and I see a pattern already, right? I've written 2 whole tests, and I can see they're always going to be like this. Now, there are a lot of options here for how I could sort of minimize the code, dry it out, don't repeat yourself, that sort of thing, make it quick and easy to read. A couple things about your tests. So your tests are an executable specification. They're an executable specification for how I expect this thing to work. It may not be working right in terms of business context, but how I expect the thing under test to work, specified by the tests. So I want this to be clean. I want it to be readable. I don't want to dry it out so far that I have to go jump around through 6 files to figure out what's going on. I call that being moist. And I know some people don't like the word moist, but I kind of use it because it's about right. It's not quite dry. There's still just enough moisture. There's just enough repetition that looking at any one given test, I can see what's going on. There are some other things here, right? One temptation might be to change this test to say, given a number return number as string, and then just do this. Now I can have a whole bunch of tests all in one function. Look at me, I'm cool, right? I'm still getting some red squigglies, which means I've made some cool syntax error. What was that? Yep, missing a tick. So I've got this. Now it's going to get mad about this is a const and you blah, 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 right? And you could fix that. Let's go ahead and fix it. I'll walk through this whole demo, right? Let, and then we'll just go ahead and say, I'm reassigning. So what could be wrong here? Couple things, right? So one, I do have a nice clear name. Given a number, return the number as a string. That does tell me what the behavior of what I'm doing is. But now I have multiple tests in here, right? And so if one of those breaks, now I have to understand which thing is broken, right? What could be wrong here would be maybe on line 8, I'm going to get a fail, or line 15, I'm going to get a fail. And now I have to slog through, in this case, 12 lines of code to understand what's happening here. That's a lot of work. I know it doesn't sound like a lot of work. I'm sure many of you are used to looking at hundreds of lines of code and trying to figure out what's going on. And I'm telling you, you want to look at 3 lines of code and figure out what's going on, or 5 lines of code, because you can make those kinds of figurings very quickly, right? So I wouldn't do that, right? I would keep each test very specific. What does this one test prove? Is that proof enough? Is it clear enough what it does? But I'm still dissatisfied with the amount of duplication in my code, because it's still, look, I have this crazy pattern over and over and over again. So what I'm going to do, and your mileage may vary on this approach, but what I'm going to do is I'm going to inline things. I'm going to get the test down to 1 line. Expect FizzBuzz given 1 to be expected of 1. That's clear, it's readable, it's simple, it's not a lot of typing. I'm going to do the same thing down here. I'm leveraging Option Command N on my Mac to do inlining in WebStorm. Your tools may vary. I like WebStorm, it's got some really cool stuff, and because JetBrains has provided us with an array of tools for all the things, all my hotkeys are more or less the same. So I've done that change. It's really kind of a big step to do them both, but I'm pretty confident about this. I'm going to hit run. I'm going to make sure that I didn't break anything. Cool. So there's my refactor step, and I'm going to say git commit all changed files with the message clean up tests for readability. I'm going to try to spell readability correctly too. All right, so I've cleaned up the tests for readability. I'll run one more time. I love running the test. Makes me so happy to see that little green light. So we've created these 2 tests. Given 1, return 1. Given 2, return 2. This pretty much inclusively tests all inputs for that. So now we can move on to rule number 2. Rule 2. Things divisible by 3 should return fizz. Awesome. That's an easy test, I think. Given, oh, hey, look, I just found a typo up here. I'll stick that N in there and we'll make sure that we're cool. I'm sure we're cool, but let's make sure we're cool. All right, cool. We'll go back to this. Test, given 3, return fizz, give me a function, little anonymous function action, and then we're going to expect FizzBuzz 3 to be fizz, and we're going to hit save, and then we've got some red curlies. What did I do? Expression expected. I always love it when I make typos and then I can't figure out what's happening. always makes me question whether or not the interpreter is interpreting right. But it says one failed. I'm just going to run it and ask it, what did I do wrong? And it says, syntax error, unexpected token 1:34. So line 11, position 34. Oh, I missed the arrow on my rocket. Fat rocket. So, typos happen. No big deal. It's easier to just run it sometimes and look at the error message and go, oh, yeah, I'm kind of typing wrong. So this says, all right, cool. I ran these first two tests. They passed. I ran this next test, and it failed. Given 3, return fizz. Expected to be, received to be expected. And I expected fizz, but I received 3. Well, we sort of anticipated that, right? We know that we haven't written any code to handle the fizz case. So what's the simplest thing we could do? That's our next question for ourselves, is what's the next thing I could do? So I'm going to do the simplest thing I can think of. Given is equal to 3, return fizz. Can't get any simpler than that. Handles specifically just the case I'm concerned with. Doesn't do anything crazy. If it weren't for those curly braces, that'd be a line of code. I guess I could take them out and get it to a line of code, but let's just leave the curlies in place. 1 passed, or 1 sweep passed, 3 tests passed, 3 return fizz. Awesome. So that's the next part of rule, or the first part of rule 2. So what would be the next possible test? So I was doing this demo a couple of days ago, and we were having a conversation about, well, should I go on to rule 3 and test buzz? Should I test for 4 because that's the next number in the series? Or should I test for 6 because that's the next thing divisible by 3? Your mileage may vary on how you get there, but what I do is I test the next thing relevant to this rule. I believe strongly that my first 2 tests exhaustively test all numbers that aren't divisible by 3. I have 1 test for one thing divisible by 3, but it won't work for 6 or 9 or any of the other things that are divisible by 3. So let's go there. Given 6, return fizz. Remembered my arrow this time. What did I forget? I forgot the closing tick. Okay, so question that rose yesterday, why do I keep typing out everything? Why don't I just copy paste? So copy paste gets you in trouble. This is a trivial example. It's probably not going to get you in a lot of trouble, but if I had just said, instead of doing that, if I had just said, hey, let's copy this. Let's copy it down here, and we'll change the input to 6, and everything will be fine, except this, we expect this to fail because we haven't written any code for it yet. But it's going to be fine, right? Except, darn it, I forgot to change that 3 to a 6. So now when I look at the test report, it says, given 3, return fizz, given 3, return fizz. So as a reader looking at the test report, what's going on here? I have 2 tests with the same name, 1 passes, 1 fails. I just created confusion for the reader. I don't want to create confusion for the reader. The reader's likely me. It's 6 months later. I've forgotten what I did. I'm running the tests before I make any other changes, and I go, hey, this test report is strange because this one is passing and this one is failing, but they have the same name. Now I have to go in here and look at this and say, what's different about these 2 things? And if this were a complicated thing with lots of setup and lots of act and lots of assert or something like that, I would be like, hey, I missed that 6. And it might take me 5 or 10 minutes to find it. So if I type things out, I personally make fewer mistakes, right? So I'll go ahead and just change it by hand this time. I'm not going to retype everything. It still says I'm doing it wrong. Why is that? Well, this time, given 6, return fizz, returned 6. Okay, so now we're back to, I need to actually write the next piece of code to handle this. So I'm going to go in here and I'm going to say, So right now, and I'm using strict equal here, I'm saying if the given thing is the number 3, right? What would be a way to get there? Well, I could do math. Math works. Or I could not do math. right? I could say, well, given 6, right? So if given 6, return fizz. Cool, this is going to pass, right? But, so that one's working. But now I would have to do that for everything divisible by 3, and that's a lot of numbers, right? So what if I thought about the math a little bit, and I said, given that the modulo 3 of given is 0, this statement means if given is evenly divisible by 3, so mod returns the remainder of the calculation. If it's 0, then we're evenly divisible by 3, return fizz, and I eliminated these 2 lines of code. That seems like the simplest thing that could possibly work. And look, it passed. Cool. Now, I'm going to commit this. What did I say last time? Something like, yeah. So, git commit all files, message, rule 2, divisible by 3 is fizz. Cool. That was quick and easy. It's all committed. I still have a comment in here, but that's okay. I'll just get rid of it this time. What's next? So again, we're left with, well, what's the next thing to test? So we know things divisible by 3. We know things that aren't divisible by 3. We could do test given 5, because that's our next rule, right? I guess I could type in the comment again. Rule 3, divisible by 5 is buzz. Return buzz. See if I can get the syntax right in the first try. Cool. And then I'm going to say I expect. If I call FizzBuzz, I give it 5. The result to be buzz. All right, and what do we expect to happen? We expect this to fail, and we expect it to return 5 instead of buzz, because we've written no code to handle this case. So we'll run this. Hot diggity dog, it failed. Kind of what we expected. Expected buzz, received 5. So no surprises, we got what we expected. Seems like, probably, we can do the same thing we did last time. Now, there's a temptation. We'll go back to our cut and paste problem, right? Or copy paste. There's a temptation to just copy that and make a change, like given mod 5. Again, I would avoid the temptation. I would make the simplest step possible, given 5, return buzz, I can't type, return buzz, right? And why would I take that step? Why not just jump ahead? This is a trivial case. I'm not going to mess it up. But in a more complicated case, I might copy it and then overlook some other special rule. There's some other special rule that says, for example, divisible by 5 but not 20 or something, and then I'll have a test that passes now that might break later, or passes erroneously for 20 or something like that. So baby steps. Think through all the little things. By having this discipline, it causes you to think of all those little, edges and funny bits, and you get a better result. And it only takes a few seconds. If I were doing this full speed, I'd probably be done by now. Cool. So given 5, return buzz. That's passing. Awesome. Let's go to the next step. What's the next most reasonable thing? Well, let's follow the pattern we used before. Given 10, return buzz function right, and then go in here and say I expect FizzBuzz 10 to be buzz, and I'm going to run that, and I expect this one to fail because I haven't written a rule or done anything to handle all things divisible by 5, and it failed. and it failed for the expected reason. I expected buzz, but I got 10. Cool. So we're making good progress, and we know the pattern now. We've seen this before up here. All right, given mod 3 then becomes fizz. We'll do the same trick here. We'll say given mod 5, 0, return buzz, and we'll run our tests. Sweet, it all passed. That's exactly what we expected. So we'll do a little, make sure we've formatted our code, do a little code cleanup. This time we'll remember to remove our comment. We shouldn't need the comment, right? There are ways in Jest to put describe blocks around things, and we can, describe rule 3, hopefully I won't mess this up, I don't usually do this. Divisible by 5 is buzz. Don't have to type function rich. So you can do this, right? If it increases readability, you can do this and it will make your test report, if I got the syntax right, it'll make your test report read like this. Rule 3, divisible by 5 is buzz. So nice, clean test report, easy to read, right? So let's do that for everything. Describe. What will we call these? Normal numbers returned as strings. So describe blocks are really handy for this, right? And as your test suite gets bigger, that you may find this more effective, more helpful for what you're doing, because it can get really challenging. Let's be consistent here. Sorry, rule 1. I'm off script now. Can you tell? It can be really helpful to use these describe blocks, especially for very, very large test suites. We're going to talk about very, very large in just a second here, but let me finish this off real quick. Rule 2, divisible by 3 is fizz. Format action so things indent nicely, run everything. Oh, cool. Look at my test report now. It says rule 1, normal numbers returned as strings. Rule 2, divisible by 3 is fizz. Rule 3, divisible by 5 is buzz. And it's very easy to read. Very easy to read is important because in 6 months when I come back, I'm going to be like, wow, this is hard to read. I wish I hadn't done it this way. I wish I'd taken a few extra minutes to make sure that things have good names, that things have described blocks around them, whatever, right? So your mileage may vary on using describe blocks, but if you find them useful, right, you have a conversation within your team room and you agree, we're going to use describe blocks. And we're going to lump all of the things that are related into one describe block so that it's easy to track down what we're doing. Warning, I did this once on a Ruby project with a different testing tool. If you lump all of the world into one test file and you use describe blocks like this, it can get very difficult to read and very hard to track things down. So while you're thinking about that, think about, are all of these things related? In FizzBuzz, of course, they're all related. It's one simple thing, but you might want to break it up into multiple files. Things about this rule, things about that rule, just to maintain your sanity and not have too much going on in the file. Let's also talk about the test itself, right? I spent a little bit of time earlier on trying to make this one line long, and I did that, right, so that it's easy to read. Readability and the complexity of your test, right, are telling you about your design. So if it's hard to write the setup, if it's hard to write the assertion, it's telling you that your design is flawed. It's up to you to determine how flawed. But if it's hard to set things up, you've probably got a design problem. If it's hard to make an assertion, you've probably got a design problem. And you should be thinking about that as you're working on these tests and saying, wow, well, these tests are a pain in the butt to set up, and it's very confusing and it's very hard to read. Probably there's something wrong, and I need to either move closer or further away or build an abstraction to make it more clear what I'm doing. And we'll talk about that in later sessions, but those are things that you want to be thinking about as you're writing this. Too much setup pressure? Probably got a problem. Too much assertion pressure? Probably got a problem. Too hard to execute? Probably got a problem. All right, so what else? I think, are we committed? Let's go check that. Git status. We are not. Git, I don't remember what we did, so Git Diff. We added the mod 5 thing, so we can go back and look at what we typed in last time. Now in this case, I'm just going to scroll back and say, all right, that's really 3, rule 3, divisible by 5. And this is sort of like copy paste, and I'm being really careful, right? Because I just scrolled back to the previous command, but there we go. Now we're committed. Git status, all good. Run the tests again just to make sure. Can never hurt you, right? In an idealized world, I mean, our runtime there was 0.3 seconds. In an idealized world, right, all of my unit tests can run in under 10 seconds. I have other projects where I've got thousands of tests. The unit test portion runs in less than 10 seconds. The entire thing runs in 2 or 3 minutes. That includes standing up databases and configuration and the whole 9 yards. And if you can live in that world, you can run these tests constantly to make sure that you're not breaking things. All right, so what's the next thing? So we got rules 1, 2, 3. Let's go back to our README. What's the next rule? For things that are both multiples of both 3 and 5, print FizzBuzz. Cool, we can do that. So what's the first thing divisible by both 3 and 5? That's 15. Describe rule 4, divisible by 3 and 5 is FizzBuzz. Cool. So now I got a function for that. Make sure I didn't make any syntax errors. I feel like I did, but nope, it ran. Now, just so you know, if you have a describe block that's empty, nothing shows up for that describe block because it didn't do any work. The reporter doesn't report it. But I know that it runs, so that's step 1, right? Test. In the, by the way, in the README, I go through the entire process of setting up a canary test as a plumbing approach to make sure that your plumbing works. It's a good idea when you're starting a new project. You just put like a silly hello world, or in my case, hello moto test, and run it just to make sure that the test framework is actually going to execute and find your tests, so that you're not fighting with that while you're also trying to solve real, project-related problems. So let's write this test. Given 15, return FizzBuzz and function fat rocket expect FizzBuzz given 15 to be FizzBuzz. Save, run. Error, test failed. We expected that. We expect what? Anybody remember? We expect fizz because that's the first thing our code does. Given divisible by 3, return fizz. If it's not that, then we should scratch our heads and say, I didn't get the expected error. Look, it says I expected FizzBuzz, but I got fizz, just like I predicted. Okay, cool. So, things are working the way we anticipate. What do we do? What's the simplest thing of code we could write? Well, silly as this might seem, if given mod 3 equals 0 and given mod 5 return FizzBuzz. Right? right? And I put that up at the top so that I don't accidentally go past here or past here, because those things return immediately. Like if I put this down here at the bottom, oops, I'm going to get fizz again. Sure enough, right? If I put it all the way up here, now I'm going to get FizzBuzz, and it's going to pass. Cool. That's what I wanted. So look at us. In relatively short order, we've gotten ourselves to the answer. Now I skipped a step. You might have noticed I did not do a given 15 do FizzBuzz, right? That's a bad habit of mine. I've done this project enough times that sometimes I skip steps because I'm not thinking about it. Probably should have done the 15. Don't feel like re-recording this. So we've got a FizzBuzz rule, but we need another test, and I know it. So let's go ahead and add another test. Test given 30 return FizzBuzz. So that's the next thing divisible by both 3 and 5, right? Or it is a next thing. You could pick 60. You could do 45. It doesn't matter, right? Expect FizzBuzz given 30 to be FizzBuzz. Run this. Expecting it to pass because of the skipped step that I made. Yep, it passes. Cool. Now, let's first commit this. It's working, right? So let's not mess around. Let's go back up here and say rule 4 divisible by 3 and 5 is FizzBuzz. So git status, and it says we're cool, everything's done. We've got all these nice tests, they're well organized, I get a nice test report. I can even run coverage on this. So coverage is a handy thing. And you'll hear a lot of people will talk about coverage as a means of knowing whether or not we've done a good job and things, right? Coverage is really handy in the moment, at the time that I'm writing stuff. It's not very useful later. I would tell you, if you're doing test-driven development correctly, there's almost no excuse for not having 100% coverage. There are a few specific examples where creating a unit test for something is sort of over-the-top expensive in terms of your time. So you might only get 99% or 98%. But if you're really doing TDD constantly, 100% coverage is a piece of cake. So you can see here all files, index.js has 100% coverage on statements and branches and functions and lines. Completely covered. And my buddy WebStorm even puts this little green bar in the gutter to show me, look, you tested all the things. So in case you had some doubt about, did I check all the cases? Have I checked all of the code in here? The coverage report can be helpful. But it doesn't tell you whether or not you're missing a case in terms of the problem statement. You still have to go back and say, hey, problem statement, I've got this fizz thing, I've got this buzz thing, I've got this FizzBuzz thing. Haven't done anything about a program that prints the numbers from 1 to 100, and we'll get to that in a minute. You have to actually pay attention to what's in the requirements, whether that's a story card or an SRD or however you got them. And even if you got an SRD or a story card, there may be an opportunity to have a conversation with your product owner or your colleagues about test cases we didn't think of. Because a lot of times when we're writing these stories, we think about the happy path and we don't think about, well, what if the database is down? Or, what should my code do? I can emulate the database being down, but what should I do if my database is down? Should I raise an error? Should I crash? Should I try again? Should I write a log statement? All of those sorts of things need to be included in your test for what is the behavior I anticipate or expect out of this system. Cool. So we got all these cool tests. They work. They're pretty tight. You couldn't really make this any tighter. There are techniques like parameterized testing that you could use here to minimize the number of lines of code in the test suite. But like I said, we want this to be a little moist, right? We don't want we don't mind a little bit of repetition to make it clear that I expect FizzBuzz given 2 to return the string 2. But looking over here, this is our production code. We'd like this to be lean and mean, right? So what could we do here to make sure that this, or to make this a little bit cleaner? So first thing I'm going to do is I'm going to run the tests, double check I'm green. I'm green. That's cool, right? Now, I'm going to look at this code and I'm going to say, well, what could I do here? This seems redundant. I'm doing the same expression in 2 different places. Given mod 3 equals 0 here, given mod 3 is equal to 0 here, given mod 5 here, given mod 5 here. That seems redundant. And I know that I want to return FizzBuzz when both are true. So here's a tactic. And this is kind of a big leap. I know some people might do this in more steps, but I'm going to say let return value, let's call it result. Result equal an empty string. Okay. Then I'm going to change this to result equal. And result equal. And result equal. Okay? Then I'm going to say if result, now JavaScript will treat that as a null check or an empty string check, right? So if the result is empty, then it will bypass this if and it will run this line. If the result is present, meaning it's populated with FizzBuzz or Fizz or Buzz, it will return the result. And we're going to run our test. So that was a relatively small change. It wasn't as small as we would necessarily want it to be. Hey, and we broke something. How did we break something? Oh, well, it set result, and then it set it again, and then it set it again, right? So if we go back and we look at the output, it says, but I got buzz, which is this. Okay, didn't quite work. One baby change, but we could say else, and hit format, and now we have this awful chain of things, right? And that's not very pretty, but it does pass, right? And it's okay, right? Many people have said, don't talk about how the sausage is made, talk about how the sausage tastes. So what could we do next to simplify that? Well, let's borrow from JavaScript, right? JavaScript says that I can replace this 4-line construct by saying return result or given to string. So if result is empty, it's going to run the stuff on the right hand side. Little JavaScript sugar. That passes. Cool. All right. So we made a little bit better thing, right? What about could I get rid of this awful else if chain? It's just ugh. I mean, it hurts my eyes to look at such a thing. And the answer is yeah, I can. So what if I did this? Check this out. I'll get rid of the first thing and I will say, hey, if given mod 3 is equal to 0, add fizz to result. Now, that's not going to be enough on its own. Because what about buzz, right? If I run it right now, I expect the fizz cases to pass, the buzz cases to fail, and the FizzBuzz cases to fail. And sure enough, at least the FizzBuzz cases failed. Sort of surprised. Oh yeah, I guess we didn't have the first time they overlap is FizzBuzz. So my FizzBuzz cases failed because I'm not including the buzz. So next thing, take that else out of there. The plus equal, by the way, for those uninitiated, is effectively concatenate these strings in JavaScript. Cool, everything passed. Now look at how I have a nice short implementation. If given mod 3, do the fizz thing. If mod 5, do the buzz thing. And because of they're in this order, the FizzBuzz cases work. So just to reinforce that, if I change the order and test for buzz first, it's going to fail. FizzBuzzes are going to fail because it's going to buzz fizz instead of FizzBuzz. So my tests are telling me, are informing my implementation, and that's okay, right? But they're not, the tests are driving the design, if you will, but they're not checking the internals, right? So people talk about don't test the internals. We're not. We're simply adjusting the internals to get the right results. So all of our tests pass. This is cool. We should be excited. So now we say git commit all files with the message refactor index.js to be easier to read. Again, easier to read, subjective, your mileage may vary, but for me this is easier to read. Now, what's the next thing? Well, we need something that plays FizzBuzz from 1 to 100, right? Like the children's game. So, if we had the kids here, we would tell them the rules, and then we would go in a round robin fashion, and we would say, child number 1, you start, and child number 2, you go next, and then these are the rules. And they would say 1, 2, fizz, 4, 5, buzz, so on and so forth, right? What we're going to do is we're basically going to write a for loop. So, how would we test that for loop? Describe gameplay. We'll just call it gameplay. So what are the things that we need to know about gameplay? Well, we need to know that when we play the game, starts at 1. And I guess we should probably use the digit 1 since that's where we start. So what should be true? What should be true? Now I'm going to demonstrate again this whole starting with the assertion, right? Expect actual to be 1. Okay, that seems like we've seen that before, like up here. But I want actual to be equal to the 0th thing in output. And I want output to be the result of playing the game cool. Up here we'll, I guess we'll create the variable just to be thorough. Right? So we're going to play. Somehow we're going to get this output thing. I'll discuss that in just a moment, like where does that come from. But we're going to play, and the first thing that we get back, right, output 0, should be our actual, and we expect it to be this string. Right? So how do we make that happen? So the idea here is what's called a test double. Now this is actually beyond TDD 100. This is maybe TDD 201 or something, but it's a pretty straightforward concept. Within our describe block, we're going to create a constant called output. It's going to be an empty array. We're going to create a before each method, and before each will run before each test within our describe block. And that before each method is going to replace console output. I'm probably jumping way too far. I apologize. But this is fun, right? And then after every test, we're gonna have to replace console log again. So I need a variable to keep track of the original console log. I'll I'll just call it real logging method equals undefined. And then before each, I'll say real logging method is equal to console. So those of you familiar with JavaScript know that console log is how we barf things out to the console, right? It's Java's system out print line, or C Sharp's system console write line. And then I'm going to replace console log with my own thing. And what this is doing is saying, when somebody tries to use console log, I want you to take whatever argument they gave us as the message, and I want you to push it onto the output array. So now the first thing going out to console log will end up in that output array. Then after we're done with all of those things, console log is equal to real logging method. We'll substitute it back. And the reason that we're doing this in the before and after each, right, is this guarantees that we've made the change before the test runs, and it guarantees that we clean up after ourselves in the after each, so we don't have a side effect that it breaks other people, right, other tests. So we're going to do that. Now this is going to fail because we haven't implemented play, but this is the idea here. Starts at 1 as our first test. So we'll run this. It's going to fail. It's going to say, I don't know what play means. Cool. I don't know what play means. Play is not defined. So, first things first, let's change this to say, let's call that index. And we'll stick index in front of all of the FizzBuzzes. FizzBuzz is that method underneath, right? Oops, I don't know what I did there. Fat fingered something, I'm sure, right? And there aren't very many of these. You could do this with a global search replace. Just say find FizzBuzz and replace it with index.fizzbuzz. But since there are only like, half dozen of them, it's fine to just kind of scroll through there. Related, we're going to put index.play here. Cool. Then we're going to go and do some more JavaScript code. And we're going to say, I want you to export two things. FizzBuzz and play. And it's that underlined zigzag thing there means still don't have a definition of play, Rich. So function play takes no input. I think I really wanted semicolons there. Now I'm going to run this and it should run but fail because there's nothing in output. Cannot read property 0 of undefined. Okay, that makes sense, right? So if we go back here, output is empty, which is effectively undefined, saying I can't do that. What do you want to do here, Rich? So we're going to write just enough of play to make play work. And we're going to say return 1. Oh, sorry, not return 1, my bad. I did something goofy. Hang on. We're going to say, oh yeah, maybe that's okay. Yeah. Play returns output is the mistake. It doesn't return it. We modified output. And so what we want here is to say, I'm sorry, I had a little brain fart there. Console log 1 as a string. Now we run that. This should still pass, right? But you can see how you can kind of get in trouble and make mistakes like I just did. So you got to be careful and think about. I shouldn't have expected that to pass, but I did because I made a mistake. So no worries. I've got my starts at 1 test method. It does exactly what I thought it would do, right? I ran it. I expected it to start at 1, right? So now let's do the next test. We know that the range of our stuff is 1 to 100. Ends at 100. Now, 100, conveniently, is divisible by 5. So we should get buzz, right? So const expected equals buzz index play const actual is equal to output 99. Notice the shirt off by 1 errors. 99 is the last thing in an array of 100 elements because it starts at 0. Expect actual to be expected value. I think I spelled everything right. Okay, ends at 100. I expected to get buzz, but I got undefined. So what's the simplest thing I could possibly do to make this work? Well, it's a little over the top. I could do a big set of if-then statements that say if I've got this, you know, if this is the call, I could basically do this, right? And that would get me passing. However, I'd need to fill in 98 more of these to get that array right. Well, that seems a little crazy. I've got this handy dandy method up here called FizzBuzz, and I know how for loops work, so let's try this. For let idx equal 0. idx is less than 100 because we already know these are constants. We don't need to mess with them, right? idx plus plus. That gives me a standard for loop. It's just going to roll through there 100 times, right? And then I'm going to say console log the output of FizzBuzz given idx. That should work. Run. Error. Expected 1 got FizzBuzz. So what mistake did we make here? We need to add 1 to this or change the indices. Start at 1, because again, our game plays from 1 to 100. Look at that, it passed. If we expand this all out, starts with 1 passed, ends at 100 passed. Are we confident that this works, that we've got the whole game working? I think so. So let's go check that in. Git status. Git commit all files with the message gameplay. Print numbers from 1 to 100 using FizzBuzz rules. Now, those of you not familiar with JavaScript, in your package JSON, you can define things, and I've defined a start that plays the game for us, right? In order to make that work, we go over here and we say play. Let's run our tests again. That won't impact them, right? But this says when you run from the command line, call the method play, which does the looping, which calls FizzBuzz. So when we go back to our terminal, we say npm start, and look, it printed out all of our cool numbers. So scroll back a little bit. You can see 38, 39 is divisible by 3, so we got fizz. 40 is divisible by 5, so we got buzz. 45 is divisible by both, we got FizzBuzz, and it ran all the way out to the end. So that's pretty cool, right? Git status, we should have 1 change to index. Git commit -a -m, add play, call to index.js so that it plays when you run. Git status. All right, cool. So that's the whole shooting match. We have implemented FizzBuzz according to its rules. We have written a program that writes the numbers from 1 to 100, where multiples of 3 are fizz, and multiples of 5 are buzz, and multiples of both 3 and 5 are FizzBuzz. So I hope that was helpful. Obviously, any questions, shoot me an email, find me on Twitter, post comments on the YouTube video when I publish it. And I thank you for your time this afternoon.